So the way we differentiate between underground nuclear explosions and nuisance alarms like earthquakes has to do with the information we pull out of waveforms and the data that are provided by the International Data Center. The Comprehensive Test Ban Treaty Organization has deployed a global network of sensors to monitor for underground nuclear explosion. And the International Data Center uses advanced techniques to eliminate nuisance alarms and hand high-quality data to the nations that have signed the treaty. The nations then do their own assessment using this high-quality data. Not only do they get a latitude and a longitude for the event, but they also get a depth estimate of the event. And when you propagate the error in the process of getting that estimate, you get a confidence region that looks like a football. If that football is really deep, then we can walk away from the event and say it was a nuisance alarm. If the football touches the surface of the Earth, is more shallow, we look at the way in which the energy is coupled into the rock. And so what we do is we look at the way in which those energy patterns are observed in the waveforms and use some clever mathematics to differentiate between a potential underground explosion and a nuisance alarm. When an underground event happens, either an explosion or a large earthquake can pump the atmosphere and create an acoustic signal. You can cleverly integrate those signals and still get a very good location of the event. Potential underground nuclear explosions could be chemical explosions, but an underground nuclear explosion can release gases that are indicative of a nuclear weapon. And those gases can be detected by ground stations to determine if the event was potentially nuclear. It takes a weapons lab to find a weapons lab. We do all things nuclear when it comes to research for explosion monitoring.